So I'm just going to start off and then hand over to Dan, but I just wanted to say, kind of put it in context, our MATLAB journey. I actually started with a chemistry degree. I decided I didn't like cooking in the lab, so then I kind of chose to do a more computational work instead. And then I came across MATLAB in about 95 when I was doing a postdoc, and I've stuck with it ever since. In those days, I had something like 20 floppy disks to install. Then it went to CDs, and now you just download it from the cloud. I work for Shell in the Advanced Analytics Center of Excellence. My job title is given by Dan to me, which is very boring, is Senior Business Analyst. I'm not quite sure, even to this day, what that means, but I hope I do a lot more. So I'm going to hand over to Dan to kind of tell you about the Advanced Analytics COV, which has been mainly driven by him, and then we're going to share some examples of how we've applied and deployed MATLAB-based solutions.
I'm Dan Jevons. I lead what's called the Advanced Analytics Center of Excellence at Shell. Just to explain how we're structured, we sit within what we call technical and competitive IT, which is basically our R&D for IT division. That's the best way to describe it. So we're focused on trying to build differentiated technical product for our business that's either going to differentiate us in the marketplace or else is going to build future business models. That's what we're all about. We're going to do a bit of a double act today, so what I thought I would do, I'll hold my hands up and say I'm not a MATLAB user. My background is really big systems implementation, developing applications for the enterprise. And my passion throughout my career has really been process improvement. I started out my life doing statistics around Lean Six Sigma type stuff. And since then, I've really been focused on saying, how do you apply the sort of things that we're talking about today, and we've seen through some of the keynotes, in the context of business reality? So what you'll get from me is a bit of an overview that says, where are we going as a company? What is this term digitalisation all about for Shell? What are we trying to achieve? And then Amjad's going to talk specifically about how MATLAB fits into that whole equation and the work that he's been driving with MathWorks. So I have to do this, I'm sorry, I apologize in advance. This really says, firstly, please don't use anything I say today to invest in Shell shares. And secondly, the opinions I'm going to share are my own and not those held by Shell and its wider entities. What we'll do, just to briefly walk over what we're going to cover. I'll talk about Shell a bit, give you a bit of an idea of what we do as a business. I'll talk about the energy challenge that we're currently facing. It's a key time for our industry, and it's important to put this in that context. I'll also talk about our digitalization strategy and then how we do things. So what are the processes that I've put in place in terms of how do we develop the digital products that I'm referring to? And then, like I said, Amjad will go into the use of MATLAB, and we're going to talk about a very exciting use case, which actually where MATLAB has been deployed as part of the monitoring technology above our carbon capture and storage facility, which is called Quest, and some of you will have seen it in the news. And then we'll talk a little bit about where we're going and what we're hoping to do next. So let's talk about Shell. We're a huge business covering a vast array of different things, really. So we're an integrated oil and gas company by heritage, moving towards an integrated energy company. And if you look at what we currently do in our activities, it goes right from exploring for hydrocarbons through the development and extraction of those hydrocarbons, the trading of that, the manufacturing of products associated with that, the sales of that into markets, and also the transportation of all of the above. So it's really a massive, diverse operation, global reach, and also starting to build newer businesses around things like wind energy and biofuels. And of course, things like carbon capture and storage are becoming increasingly important. So if you take anything away from this, it's a massive, diverse portfolio. Now, the great thing for me and the thing I love about my job is I'm not constrained. So my job is to play across this entire value chain and say, where does advanced analytics and digitalization add value to this business? So that's a great assignment. It means I have a lot of freedom, which is great. But let me tell you what's motivating me at the moment. This is actually what I care about. I think ultimately we are, as an industry, in a situation where we're hitting a point of energy crisis. So the world's population is growing dramatically. Not only that, but those people are moving to cities. They're expecting higher living standards. They're starting to use vehicles. And so we expect that over the coming years, energy demand could double from its 2000 level. But at the same time as this growing demand for energy, we've also got the inverse problem of global warming, where actually we've got to do something about CO2 and climate change. And so part of that, the answer to that is efficiency. Part of the answer to that is an energy mix. But I'm going to say something beyond that, and I'm going to say part of the answer to this is digitalization. What do I mean? We need to do things smarter. The technology that we have today, and some of the technology that's being showcased at this conference and others, actually gives us the opportunity to do things in a different way, to change the way people do their jobs. And I think there's a tendency, for me in the past as well, to develop applications that I like doing. The question for me is not that, but how do I change the way in which a person in the business doing a job does their day-to-day job? How do I give them, and I'm calling them at the moment cognitive agents, smart systems that help give them better answers to their day-to-day decision-making and take out all of the Excel nonsense that we have running across our enterprise? So that's the problem statement. How do we do that? And if we can do that, I personally believe that digitalization and the work we're doing can play a role in the new energy future. So what are we doing to try and impact that? Well, what we do is we partner with the business, so we work across that value chain that I talked about. We work with our R&D division and with our vendor ecosystem, and we try to develop technology across upstream and downstream, and also enable some of our projects and technology. So that's really what we're trying to do. Cut across the value chain, deliver those digital products that are going to differentiate within the business. What I also want to say is this digitalization agenda it's not new, really. It's not a one-off thing. It's not something that's only in the future. I think the key thing here for me, and when I talk about this slide, I always actually get my phone out of my pocket. Because the key point is, I spend most of my time and most of my computer interaction these days is with my phone. I'm probably rather addicted to it. I think most of us are. The point is, in my phone, I craft my own digital experience. I have 3 music services running. I have multiple email accounts. I have the ability to administer my own servers. I can even write MATLAB code on my phone now, hey? You got the plug in there. So, you know, the point is, ultimately, we're moving more and more to this mobile-enabled device. So the question is, how do we create these digital experiences within the context of what regular knowledge workers are doing within the enterprise every day? And how do we make sure that those people make the right decisions in an efficient manner that drive the best outcomes for the company? So we've come up with a way of addressing that, and we call these our digital themes. Some of them are really obvious, like it's going to be mobile first. I talked about that already. It's going to go to the cloud. That's a given. But there are a bunch of other things which are starting to emerge in our world, which are actually cumulatively allowing us to deploy digital product. And Amjad will talk about the Quest solution, which I think is a great example of digital product. So for me, what's interesting is it's the collection of these themes brought together into those digital product sets that's actually going to drive this change. And you'll see more of that as I talk about what we're doing with the Quest solution. So how do we do it? So we have a standard process that we go through. And what we try and do is we try and take really a standard ideation process, gather the ideas, get people to say, what would make my job easier? What are the things that we can do that would drive value? And we run some competitions, we do crowdsourcing internally, we also go out and run design thinking workshops, and we use that to populate the funnel with ideas. Some of them also come from our own teams, and then we refine those. We refine them through a framing process, we run a rapid prototyping exercise, we develop a POC, which we make, a proof of concept I should say, which we make available to the business to play with, and if it works, we write an investment proposal and we turn it into a production solution. To give you an idea, when I started, we were doing about 5 a year. At the moment, we're doing about 40. And next year, I think we'll top 100. So it's that ramp up of deploying these interesting, innovative digital products, and some of them are extremely exciting. And they range from things like supporting the inventory analyst with their stock counting and stock analysis on a day-to-day basis, trying to optimize the level of spare parts we store in our warehouse, working with some of our analysts around understanding which crudes we process and how they make the choices about which crudes to process within manufacturing, working with, for example, our HSSE central team, looking at how we can better assess the risks that we're running every day in the field using data rather than intuition. So just some little examples, but it gives you an idea of the sort of thing we're talking about, and these are the products that we're pushing through the chain. So I'm going to talk really briefly on this slide, because I'm conscious I'm getting close to my allotted time, and then I'll hand over to Amjad to go into a bit more detail about what we're doing with MATLAB and MathWorks. What we do as an organization, so I talked about our process already, we use that process and those ideas to build a platform, and it's really important you understand that. So what we're doing, as we're running those ideas through the funnel, we're also building out a technology platform which lets us go faster. So I talked about the 5 to 40 story. The reason we can go 5 to 40 is replication. We do the same things over and over again from a technology standpoint. And to do that, we have to have a platform in place. So we're working with multiple different technologies, MATLAB being one of them, to bring together a cloud-based platform which we can build our stuff on top of. The second piece is then what I've talked about already. So we showcase the capability of the platform through the POCs, the proof of concepts that we run. So in other words, we demonstrate to our businesses the art of the possible by highlighting a key business problem, focusing on a single persona, and demonstrating how their life can be made easier using this digital platform. The third bit, and the most important bit of all in this whole journey, is column 3. And column 3 is very similar to what MathWorks are trying to do with the community. We are trying to do that within Shell. We're trying to build a community of analytics professionals that know the art of the possible, can use the platform, can frame things and identify the value themselves, and then deliver, off the back of that, their own digital product. So this is about empowering the masses to actually deliver their own products. And so the network is now about 400 people within Shell. We run probably between 2 and 4 events a month, and we continually showcase use cases, good practice, data science techniques, new technologies, and what can be done. And this process here is what we're using to actually now democratize this and push it into some of our bigger delivery organizations, because if it stays with us, the innovation dies. If we make it part of the way Shell does business, we change the way the company operates. And that's actually what we're about. Might seem a lofty goal, but I think it's an exciting one. So that is all I wanted to say. As you can probably tell, I get very excited about this theme, so thank you for putting up with me. I know it's a rather different talk from what you've heard from others. So now I'll hand over to Amjad to talk more about how the work with MATLAB plays into that.
Thanks, Dan. That was all jolly interesting. But obviously, you've got a breakdown of what Shell is. There's lots of different businesses. These are the key business areas. And over the years, so I'm going to talk about CO2 management, which is a Quest project. But over the years, MATLAB, to my knowledge, and probably elsewhere, has been used in these businesses. Some of them probably not boxed because I'm not aware of them or not heard about them. Integrated gas is obviously an area we need to go and investigate and exploit and see why aren't they using MATLAB. But some of these things like pipelines, we have MATLAB-based solutions connected to instruments doing corrosion measurement monitoring, so you can do statistical forecasts of see whether you need to kind of go and replace the pipe. MATLAB has been used in treasury cash forecasting, which actually has been productionized in a slightly different way last year, but actually it was a MATLAB-based solution where it was taking all the transactional data across several Shell businesses from several different ERPs and trying to do a daily cash balance to see if you've got positive monies or negative monies, or whether you have to go to money markets to basically come level. But that solution's been taken forward into production, so that was our first use case. Elsewhere, it's been used for, say, lubricants blending. So these are your products, Helix, 5W40, 5W30, whatever. You want to produce on-spec products. You've kind of got to know what your starting materials, what the key characteristics of those are, and then blend them accordingly so you can get on-spec products. If you get it wrong, Shell gets fined. And if you go back into the financial pages, you will find those incidents have happened in the past, particularly in China, where regulation is strict for a whole different plethora of reasons. Chemicals, monitoring, operational excellence, it's a kind of across the board. So what we've talked about in terms of opportunities and use cases from our perspective, we want to kind of pick and choose those that we can take from where it's working at the moment and put it out there in production. We call it production. It's available for whoever the technologist, the analyst is on the ground. Next slide. Yeah. So the example I'm going to talk about is Quest. Quest is basically a monitoring scheme that's been put in place for a carbon capture and storage installation in Canada. We have assets there, an open cast mine you can see a picture of there, which is basically scooping up lots of thick bituminous type products, and we're trying to extract oil out of them, and that's been done at one of our assets in Scotford in Canada. It's called an upgrader. So what that whole process produces a whole dense CO2 phase, which has to be kind of handled some way. The open cast mines is a significant asset of ours, producing 255,000 barrels of oil per day. And our license to operate from the Canadian government is that for us to do this work, we had to have a solution to manage the CO2. And the management of the CO2 with funding from the Canadian government was to build, and I think it's probably the first CCS installation, particularly for an energy company, on this scale. So we had to inject the CO2, so there's a dedicated pipeline from the Scotford upgrader to, probably runs a couple of miles along to a particular field, and there's some 3 injection wells, and the CO2 is buried deep into the ground. And as I've already said, without this solution, Shell would not be allowed to operate in this area. So, obviously, the challenge for Shell was significant. You know, this is critical for Shell. If you look at the public records of our operations, the Albion Sands operations is a critical part of the amount of barrels of oil produced. We've got clear mandate from the Canadian government of what we need to do, and therefore we had to set about trying to build a solution for monitoring. The monitoring solution came about with collaboration with a third-party instrumentation company, probably, I think, US, Canada-based, who developed this kind of laser technology, which basically will scan the surface every minute, every hour, every day, day and night. And we had to then be able to take that data and build some algorithms to do some surface monitoring and take into effect day-night, seasonal effects, and also weather. Okay, do you want to just go to the next one? So what we're talking about is, so in the top part is actually the landmass. So you've got 3 lasers, 3 pads, the same laser. So the laser kind of goes into continually from one pad to the next, and then back again, all day, all year. The data is captured, and you can see these boxes locally. And from local capture, we need to get out that data. We need to kind of push it through the algorithms. The algorithms need to kind of process and work out if there's any leakage, exceedance. And if we're compliant, fine. We just need to store the records, and we need to make them available at any time the Canadian regulatory authorities ask for. And that satisfies them. And if we can't demonstrate that we have the data, or clearly we haven't reported when there's a leakage, then there would be severe consequences. There's a little diagram at the bottom. You can see all the different geological layers that you have to go through, but the CO2 is stored at the bottom through the injection wells. Obviously, we assume that there's sufficient amount of sealing in that layer and the layer above to kind of keep the gas in place. But we have to have the monitoring scheme to be able to do it. Next one. Okay, so the way this project kind of took flight in our area was that, so in my previous role and my previous colleagues, I don't sit that far away from them, and I overheard them talking one day about having built this solution, and actually they were running it in a manumatic kind of way. They were having to do an FTP transfer get the data, run it through their algorithms, actually on desktop, and then send the results to someone who would kind of store them and save them. Actually, we were looking for a particular use case that we could kind of demonstrate MATLAB technology. We'd purchased a MATLAB MPS server the year before, and it just seemed to be like a perfect fit. And so we just had a conversation. Credit to Dan, we've actually built our own advanced analytics lab. It's a sandbox area. We're free to do what we like. We're free to evaluate technology, and we will be evaluating new bits of the features that we mentioned so far. So we just said, we think we can hook this up, we think we can deploy it, and we think we can test, so let's give it a go. And I think that whole exercise took less than a month to do. MATLAB actually did come in, help us refactor the algorithms a little bit to make it more efficient, and actually that's been a super exercise, because I then overhear my old teams going and telling their colleagues, saying, actually, if we write them as classes and call them within a particular type of template, it's going to work better. And so, that's been super useful. So from our advanced analytics labs, we had it up and running, and we had it up and running and demonstratable to the business for best part of 3 months. And it wasn't a big struggle to kind of secure funding from their local IT to say, actually, it's got to move from where it is to in a more secure, supported environment. So therefore, we need to move it from sandbox to what we call acceptance environment, ultimately production. So that's been happening this year. As in with big organizations, there's always a whole degree of politics to go through. So there's a date saying it's deployed October 2016, which is true, but actually it's been in place and running in about 3 places continually for the best part of 14 months probably. So our data lab is super useful for doing these things. Do you want to do that? So for those that really want to know what the solution, the architecture looks like, this is it. So Boreal is the company with their lasers. Their data is captured locally and then sent by cellular modem, file mover transfer into our environment. So this is done on a daily basis, so we get daily data being captured locally on site, and then there's a scheduler which basically says, go and fetch new data, pulls it into our environment, and what we've done is architected it so it comes into our Pi servers. So anyone's familiar with kind of processing and sensory information, in big companies, OSI soft Pi servers is the way you kind of store these data sets and have them available for history matching and so forth. So it sits in our what we call Pi UFL, but actually we've gone through a whole exercise of trying to make all our sensory data for all our assets accessible in a central place. So that's why we call a super collective. So in principle, if you want to actually compare and contrast the temperature on the outlet of, say, a scrubber, and you've got these units in 10 different assets spread across the globe, in principle, if you have the friendly name, you should be able to pull all those sensors at once and look at all that data and then start doing wonderful analytics on it. So that's why we have a super collective. We make that available based on the tags that we want through what we call the value service. The value service, basically, the MATLAB CTF has a bunch of calls which pulls the data at the time of scheduling through a DLL, .NET DLL, processes the results, pushes it back into the results back into the server, so we've got them for compliance, and then you can visualize the whole thing, and actually we're visualizing in Pi Process Book, but also using Power BI now, so that needs to be adapted. So what we're talking about is 75 measurements that we're pulling from site, and we're writing back a whole bunch of results there as well. And we've got weather data. So what has to happen is you need to kind of deconvolute what the laser sensory results are and deconvolute what the natural background is, take into account the weather, the time of day, seasonal things. So that's our target architecture. And then what that results in is our visualization. So the first bit is Pi Process Book. So you can click buttons, you can see exactly what's happened, And then the bottom bit, which is a bit more exciting actually, is Power BI. So I think Power BI, if you haven't come across it before, you probably will hear about it in the future, but that's going places as a visual tool and also kind of interactive tool for doing probably machine learning and code. So that's our full end-to-end solution. And like I said, it's been up and running, and we've had CEOs doing photo shoots, doing official openings of the installation, and just last month there was an updated news article on how it was going and stuff. So from our side, we're super happy. We think this is the first layer of the monitoring program that has to happen at Quest, because obviously there's whole different layers within that system that needs to be monitored and verified over time. So so that was our example use case. I think I'll bring Dan in as well. I think we just wanted to kind of say what we've been thinking of next, what we want to do with MATLAB next, and what we're excited about. So do you want to take this?
Yeah, so I'll take the first ones, and maybe Amjad can take the other ones. I think for me, I mean, I talked about it a little bit earlier on. There's a whole series of things which we're not doing that tie into the digital themes that I talked about. So I'm excited about the potential of IoT, the potential of edge computing in particular. I know MATLAB are actually doing a lot, MathWorks are doing a lot of that already. I also am very excited by the stuff that Ben was talking about, and some of the really big data problems that we have. Actually using MathWorks and MATLAB to help us solve that would be fantastic. And I'm also excited this morning by some of the smart app things that are showing with the visual GUIs and the ease of building apps. I think the thing that's interesting here with the example that Amjad showed is we've really got 3 different tiers in the architecture. So we have to do the data piece, we have to do the algo piece, and we have to do the visualization piece. And typically at the moment we need 3 people to do that. I want to be in a world where actually you need 1 person to do that, and we make it easy for that person. That's the vision of being able to deploy digital products easily, because at the moment that's still too convoluted. So bringing those things together, allowing the developer, the MATLAB developer, to also build the UI, that's exciting. The final thing I'll say is we want to try and bring it together. So Amjad talked about the usage of MATLAB being spread across Shell. One of the things I'm very passionate about is saying, can we actually start to build this into our platform more coherently, make it part of our strategy, make it an enterprise license agreement, actually make it easily accessible to people, make the toolboxes, the upgrades, the servers easily accessible to people. So that's very much the next piece of my vision for where we want to go next. I know Amjad's got a lot of other littler things that he's also concerned about.
My own vision is I want to build apps for phones and stuff. I want to use the power of MATLAB and our MPS in the cloud. I want to take images. I can think of lots of use cases on assets in the North Sea where you can take an image capture, send it back to server. It can do a whole host of database searches and find what the nearest match of this problem was before, whether it's corrosion, whether it's a fault in a piece of equipment, all sorts of things. I want to kind of go beyond there, so we've got, we're trying to trial this with a bitumen image analysis use case. For me, I don't really care if it's bitumen or I just want to use it as a way of kind of going to the different businesses and say, this works, guys, and this is how we do it. So I said at the beginning, the reason I left chemistry is because I found it a bit of like following a cookbook. Actually, I've gone full circle because what I want to do is write the cookbook for writing apps. I'd stopped kind of doing everything myself a long time ago. Dan kind of stopped me there with the boring job title he gave me. But I actually want to write the cookbook that allows people in our businesses to do it for themselves, make it simple. I've seen lots of fabulous stuff in new features that I can see will enable us on that journey. So with that said, I have nothing else to say.
Thank you very much.